Yes.
Okay, sir.
And normally books suggested SL Arora or Pradeep or Dinesh. Some of students in your class must have purchased, I think, Pradeep or SL Arora. But instead of that, I suggest all in one from Arihant, because this is a very short book, but it is more descriptive than NCERT, and it is sufficient to cover all parts and all things at the school level. And you can say some more explanation larger than NCERT, and some more question and test are there. So these two books are sufficient for the school level or any exam of a school, and these two books is for JE
Okay.
main, JE main, and some percentage of advance it also cover. When our mains level will be clear, then I will suggest more books. Suggest in initial level we will do is in JE main,
Yeah.
JE main book of Singh, JE main book of Singh. When it will be completed, then we go
Like a
for
specific
advanced
book
level.
for Singage.
What is
The
that? Singh for IIT purpose? Yes, for IIT purpose, Singh is writing two types of book. One for JEE main, one
yeah.
for JEE main. It is a volume one and volume two by BM Sharma. Writer is BM Sharma. And for advanced level, again another book that is only for IIT advanced and with of same writer BM Sharma. That is the book for mechanics one, separate book. Mechanics two, another book. Thermodynamics, another book. And electrodynamics, optics, and modern physics. Means there are about five or six book will be total of physics.
Okay.
That is for advanced level. But what is that? Initially, I am not suggesting that. I am suggesting up to here only. It is
Oh,
for main purpose. When we complete it, then we go for advanced book, advanced level book. These times, only three writers in India that is writing for advanced level book. One is BM Sharma, another is DC Pandey from Arihant, BM Sharma from Singh, and Physics Galaxy by Ashish Arora.
okay, okay.
Yes. Yeah. And when we go for foreign writer, in that case we do Irodov, IE Irodov. But initially, that I have said you have to buy only these four books, out of which I think you have NCRT and you have HC Burma.
Sir, I only have currently I only have the NCRT with me.
Okay. Okay. Now, next, I am starting the topic.
Okay.
So, initially, we are doing right now here vector. You know physical quantity.
Yes, sir.
Physical quantity. Define physical quantity.
Sir, any measurable quantity can be defined as a physical quantity.
Yes, measurable quantity. The quantity which can be measured are physical quantity. Yes.
Yes, sir.
Measurable quantity is physical quantity, right? I want to know some example. What is example of physical quantity?
It can be wait, it can be speed, velocity, uh,
Speed,
uh,
velocity,
amount of kinetic energy, and means there are like a lot of them.
kinetic energy. Tell me another name. Mass, density, force,
Acceleration.
acceleration,
Oh,
momentum, acceleration due to gravity, acceleration and acceleration due to gravity.
Okay.
Acceleration due to gravity and power, work. Yes.
Oh, yes, sir.
Magnetic field, current, charge, potential. Yes. So there are so many physical quantity, but in unit and dimension, you define physical quantity. There are two types of physical quantity. One is dependent physical,
Derived
independent physical quantity, that is fundamental physical quantity, and next one is
uh,
derived physical
which can be
quantity
derived.
or independent physical quantity. Basic of Basis of definition of these two types of physical quantity is dependency. When you say mass length time, it is independent physical quantity. To write their unit or formula, we do not require to take help of another physical quantity. While you take derive physical quantity, actually you are deriving the unit or formula of derived physical quantity from fundamental quantity. Yes.
Okay.
जैसे कि आप कहते हैं वेलोसिटी, तो वेलोसिटी इक्वल टू डिस्प्लेसमेंट अपॉन टाइम। तो वेलोसिटी जो है वो डिस्प्लेसमेंट और टाइम पे डिपेंड करता है। जैसे आप कहते हैं मास, तो मास किसी चीज पे डिपेंड नहीं करता। व्हेन यू टेक डेंसिटी, डेंसिटी इज मास अपॉन वॉल्यूम, तो ये मास और वॉल्यूम पे डिपेंड करता है, और वॉल्यूम इंडिविजुअली भी है, लेंथ, ब्रेथ और हाइट पे डिपेंड करता है। तो ये
Oh,
सब मैंने बताया, कुछ डिपेंडेंट है कुछ इंडिपेंडेंट है। जो डिपेंडेंट है दैट इज कॉल्ड डेराइव्ड, which are independent that is called fundamental or basic or independent. Yes.
okay, sir.
कोई डाउट?
No.
क्लियर है?
Yes, sir.
तो अब क्या है कि नाउ ऑन द बेसिस ऑफ डायरेक्शन, on the basis of direction there are two types of physical quantity, or you can say we did not we क्या कहेंगे, define, we define या classify physical quantity on the basis of direction, on the basis of डायरेक्शन। तो अभी जो टॉपिक हम कर रहे हैं उस टॉपिक का क्या नाम है? वेक्टर। यस, क्या नाम है?
Vector.
व्हाट इज वेक्टर? कहते हैं वेक्टर आर दोज फिजिकल क्वांटिटी व्हिच हैव मैग्नीट्यूड,
Okay.
व्हिच हैव डायरेक्शन
Okay, sir.
एंड व्हिच फॉलो लॉ ऑफ वेक्टर एडिशन, व्हिच
So
फॉलो
what's
लॉ
the
ऑफ,
law of vector addition?
यस, सो मैग्नीट्यूड, डायरेक्शन एंड फॉलो लॉ ऑफ वेक्टर एडिशन। जो तीन कंडीशन को सेटिस्फाई करता है दैट इज द वेक्टर क्वांटिटी। यस।
Okay.
And another quantity is a scalar quantity, which has only magnitude, only magnitude। यही कंडीशन है। क्लियर?
Okay, sir.
ठीक है। अब मैं कुछ एग्जांपल लेता हूं। एग्जांपल ऑफ वेक्टर क्वांटिटी देखिए। नाउ वन क्वेश्चन फ्रॉम यू, व्हाट इज डिफरेंस बिटवीन डिस्टेंस एंड डिस्प्लेसमेंट?
So one difference can be that distance is can never be negative, whereas displacement can be negative.
Hmm.
Displacement is the shortest path between 2 points,
Hmm.
and distance can be a longer path or a shorter path depending on
Yes.
what the directions are.
In this case, I means distance is non-directional while displacement is directional. So displacement is a vector quantity.
Yes, sir.
Similarly, what is distance between speed and velocity?
Difference, that's difference can be the difference.
Hmm.
Sir, I don't know. Can you please tell?
देखो यो speed equal to distance upon time.
Yes, sir.
Velocity equal to displacement upon time.
Yes.
Here,
No, but what would be the difference? Like,
I am
in,
telling you, a scalar quantity, distance is a scalar quantity.
yes, sir.
Since velocity is derived from displacement, so velocity is also a vector quantity, while speed is a scalar quantity. It does not have direction. Doubt है?
Um, but sir, like, we have a difference for distance and displacement. Like, they can be negative. Like, distance can be negative and like.
Similarly, velocity can be negative.
Okay.
Speed cannot be negative. There is a similar phenomena. Velocity can be zero.
Okay, so just wanted to ask that.
We will do more detail after some time, but right now we are taking only example. When we elaborate example, it will be more clear.
Okay.
Next one. Again, acceleration is vector quantity. Force is vector quantity.
Okay, so.
Momentum is vector quantity. While mass is a scalar quantity, density is a scalar quantity, area is a scalar quantity, length is a scalar quantity, volume is a scalar quantity, work is a scalar quantity, kinetic energy is a scalar quantity, power is a scalar quantity. Yes,
Okay, so.
you have also write some example. I will send you the PDF, whatever writing. But
Okay.
again, you write because when you will write, there will be some practice and it will fit in your subconscious mind.
Okay, so. So should I write the examples like speed, mass, density, area?
Yes, 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 yes.
Okay, please show. Sir, written.
Okay. Next. Now, representation of vector. Suppose we are writing, suppose A is a quantity and it is vector. In that case, we will take a arrowhead, arrowhead, or we will write A as a bold letter.
Okay.
So there is a symbol of a representation of vector. When we write simply A without bold, without arrow, it does not represent it is a vector. It
Okay.
shows only magnitude.
Okay.
So B, it is a vector.
Okay, sir.
When we require magnitude of B, in that case we will represent is this. Modulus of B equal to magnitude of vector B. Magnitude of vector B. Yes.
Okay, sir.
And by symbolic, when we take a line, so must we put arrow for representation of vector.
Okay, sir.
And if we are writing B and direction of arrow is towards right, when we will say the same magnitude towards left, it is a negative of B. Same magnitude, direction reversed, negative of B.
Okay, sir.
So here are two things. How we find magnitude? Modulus of B, modulus of vector B. In that case, vector of B, modulus of B becomes B. It shows only magnitude.
Okay, sir.
It shows only magnitude. But
Oh,
in this case, it shows, and this represents direction.
okay, sir.
And a starting point of the vector. So suppose this is a vector C. So this is called tail of vector. Tail or a starting point.
Like the okay. Okay,
A
okay.
starting point, and this is arrow part is called head
Okay, sir.
or final point or final position. Head. Yes.
Okay, sir. Okay.
ठीक है.
Okay, sir.
Now addition of vector. Addition of vector. For addition of vector, there are 2-3 methods.
Yes, sir.
Suppose a vector and another vector is B. We have to add them.
Okay.
We have to add them. You have to write three statements for addition. Number one, draw first vector. Second, put tail of second vector on head of first. Third, resultant is from tail of first to head of second. Head of second vector.
Um, Sir, written.
Okay. Now we are applying these three statements in this question. Initially, I have taken vector A and vector B.
Okay.
As you have said, draw first vector. Let this is question. Draw first vector. First vector is A. We have to put tail of second. So this is first and this is second. So tail of second on head of first without changing its direction and magnitude. Without changing the direction of magnitude. Direction of B is like this. So we have to put like this.
Okay, sir.
This is B.
Okay.
Draw first vector, first statement, put tail of second on head of first. So this point is tail of first and head of second, and resultant will be from tail of first to head of second. Yes.
Okay.
So this will be resultant. Yes, this will
Oh,
be resultant. This is tail of first. This is head of second. So this is resultant.
okay, sir.
This is resultant. Or
Okay, sir.
Soria, you speak these three sentences. You speak
Draw
this.
first vector,
Hmm,
put tail of second vector on head of first.
hmm,
The resultant
hmm. Is
first head of second.
hmm. Means resultant is from first vector to second vector. From tail of first to head of second vector. Yes.
Yes, sir.
Okay. Now we are writing here 2, 3 drawing. That is the question. In which question you apply these
So
three
can
rules.
I please look at the this again? Yeah, I'm just confirming that I have written it about. Oh yes, sir.
Okay. Shaurya, you do these three questions.
Okay. Good.
Shaurya, what is your routine in during daytime?
Routine as in,
Means in any class is these days going on daytime. I think school is closed.
it would be on Friday. Like Friday तक school है अभी हमारा.
Okay. So what is that? In Thursday, in Friday, this Friday,
Yes.
I will not take class in evening. So instead of Friday, I try to keep class tomorrow evening.
Or what can I do? Actually, our online class is going on, so you can on Friday if you want, like in the morning if you want, because I think I'm not available tomorrow.
Tomorrow evening you are not there.
I think so, I won't be there, but
Okay.
you can take it on Friday if you want, like in the morning.
What is it? Friday, it will be, I think, more busy time. It may हो सकती. It is whole day busy schedule Friday. So that's
So
why I.
yeah.
Otherwise, I will keep it on Saturday.
Okay, Saturday is fine, yeah. It
Okay.
Because actually I don't know when would I be free on Thursday, so that's why I don't want to take any chances.
Okay. No problem. No problem.
So
And
basically,
school is
sir, what do we
school
have to do in this question? Can you please like explain
just
like
drawing, just finding the resultant vector.
resultant vector? Okay.
Drawing, just drawing.
Okay.
In this case, I find a resultant. This is resultant here.
Okay, yes, sir, yes, sir. Resultant vector. So for the first, I think we have to place the tail of B1 at the head of A1,
Yes.
right?
Without changing direction and magnitude.
Yes, sir.
We have to shift such a way that its direction and magnitude do not change.
Okay. Um, for the second, I think I think it would for the second one, I think it would be from the
I'm let it first vector is already drawn. Let it.
yes, sir.
We have to put second tail of second on head of first
Yes, sir.
without changing in direction and magnitude. So
Yes,
this is
sir.
tail of second, tail of first, and sorry, tail of head of second and tail of first. So we have to like draw like this, and resultant is from tail of first to head of second. So this is resultant.
Okay. Um, for the second one, I think we have to join the head of A2 to the tail of B2.
Uh, it would be like this.
And what about the B1? B1 would be left alone then. Oh no.
In which case?
Okay.
First case.
Okay, okay.
I have shift
Then
here. I have shift this point to here.
so sir, I think what we would do in the third one is connect the tail of A3 to the head of B3.
Yes,
Yeah.
like this.
Yes, sir.
And this will be resultant. Is it clear?
Yes, sir.
Okay, next one. Now fourth, suppose question is this is A4.
Which is A4?
First one, and this is B4.
Okay.
In question fifth,
On the same direction.
yes, this is A6 and this is let it B6. So in this case, what will be resultant? We follow the same rule in this case. Draw first vector. So let it first vector is already drawn. Put tail of second on head of first. So tail of second on head of first. So resultant is, so we are drawing, this is second and resultant will be from tail of first to head of second like this. This will be resultant. This will be resultant.
Okay, sir.
If doubt, we make another image like this, like this is first vector, this is second vector, first vector, second vector, and this is the resultant. Resultant is this. This is A4, this is B4, and this whole is R4. We follow the same rule, draw first vector, put tail of second on head of first, and resultant is from tail of first to head of second.
Okay.
What about this one? Question fifth.
Um, we would Sir, I don't get that. I don't know.
Use simple rule. Draw first vector. Show A6 is first vector. Yes.
Okay.
And this is tail of first. Sorry, head of first. This is tail of second. We have to put tail of second and head of first
Okay.
without changing its direction and magnitude.
Yes, sir.
In this case, B6 would be, this is B6.
Okay, sir.
And resultant is from tail of first to head of second. So this is resultant.
Okay, so
I
okay.
mean, resultant will be shorter than B6, or it may be, it follows the rule. It may be larger or shorter depending upon the shape, size, direction.
Okay, sir.
This is the finding a method of vector addition or resultant but by just drawing it.
Okay, sir.
Yes, but mathematical analysis is different. Now we will do mathematical analysis, how to find direction and how to find resultant, magnitude of resultant vector, and direction of resultant vector. So,
Yes, sir.
and that is called analytical method of vector addition. Analytical method of vector addition. Direction and magnitude. So yeah, in
Yes,
physics,
sir.
in physics, what do you mean by direction?
Direction as in, how can it be described?
Yes. It is important in physics particularly because everybody knows direction, but
Okay.
the direct meaning of direction in physics is different from all other direction. Generally, when we ask what is the direction, you will say there are four directions: north, east, west, south, and upward, downward is direction, horizontal is direction, vertical is direction. Yes,
Okay, sir.
but when we there are infinite number of direction.
How?
Well, that I am telling you. Actually, every angle is direction.
Okay.
Every angle is direction. When
So,
in physics, it is asking you what is the direction. In that case, you have to tell the angle with which a certain thing is inclined with x-axis, y-axis, or z-axis, or from north, east, west, south, or vertical. What angle from vertical? What angle from horizontal? What is the angle from north towards east, or what is angle towards east towards south? Like this.
okay, sir.
It means that when we take 1 degree from north and 0.5 degree from north, so these are two different directions.
Okay, sir.
Yes, सपोज करो एक पायलट एरोप्लेन चला रहा है और दिल्ली से नॉर्थ से 0.5 डिग्री पे चलता है और दूसरा 0.1 डिग्री पे चलता है. After 1000 kilometer, their destination will be very far from each other.
Yes, sir.
So their direction are different.
Yes, sir.
And direction is represented in terms of angle.
Okay.
Clear है?
Yes, sir.
तो जब भी फिजिक्स में डायरेक्शन पूछा जाएगा तो आपको एंगल निकालना है. ये ऐसा नहीं कि नॉर्थ ईस्ट वेस्ट साउथ नहीं होगा, ये भी होगा, वर्टिकल ये भी होगा, बट इन शॉर्ट टर्म एंगल निकालना पड़ेगा.
Okay, sir.
ठीक है.
Okay, sir.
नाउ नेक्स्ट A and B are two vector. Angle between them is theta. Yes,
Okay.
A and B are two vector. Angle between them is theta. We have to draw a parallelogram A and B. And this is resultant R. This is resultant R.
Okay.
आप ऐसे समझो कि अगर हमने जो पहले प्रीवियस में हमने जो ड्राइंग किया है ये उसी ड्राइंग का पार्ट है.
Okay, sir.
हाउ? ड्रॉ फर्स्ट वेक्टर. So I have taken first vector is A. Second vector is our is B. So we are putting tail of second on head of first. And resultant is from tail of first to head of second.
Yes, sir.
So R is the resultant vector.
Yes, sir.
And resultant R, which is inclined with A with angle beta. So beta is the angle of resultant with A, while theta is angle between vector A and B. Theta is angle between given vector A and B, where R is the where beta is the angle of resultant with A. क्लियर नहीं है? ए और बी के बीच एंगल क्या है इनिशियली? थीटा.
Yes, sir.
आर ने ए के साथ क्या एंगल बनाया है? बीटा.
Uh, yeah.
बीटा एंड दैट इज द डायरेक्शन ऑफ रिजल्टेंट. बीटा, दैट इज एंगल.
Okay, sir.
ठीक है, अब हमें आर की मैग्नीट्यूड निकालनी है. मैग्नीट्यूड निकालने में देखिए हम क्या कर रहे हैं. ओ एक्स वाई, एक्स एक्सिस को एक्सटेंड किया थोड़ा सा, इसको भी एक्सटेंड किया. कंस्ट्रक्शन का पार्ट 90
Y-
डिग्री, 90 डिग्री. दिस इज बी, दिस इज थीटा. क्या डाउट है?
अभी तक तो कुछ नहीं.
यहां तक क्लियर है? जो हमने लास्ट में ड्राइंग किया है, कंस्ट्रक्शन एक्स्ट्रा लिया है उसमें,
Yes, sir.
इसमें डाउट है?
No, sir.
नो. नाउ इन ट्रायंगल एक्स एम, इसका एन ले लो, एक्स एम एन, साइन थीटा इक्वल टू एम एन बाई एक्स एन. यस.
Yes, sir.
एंड एम एन बाई एक्स एन इज बी. So mn is b sin theta. So
Okay.
this is b sin theta. Yes.
Yes, sir.
Again take cos theta in that angle. Cos theta. Cos theta is xm by xn. xm by b. So xm is b cos theta.
Okay, sir.
So this is b cos theta.
Okay. Okay, sir.
बढ़े आगे.
Yes, sir.
Now in triangle OMN. In triangle OMN, we have to find out resultant, that is ON. ON, which is R by Pythagoras theorem. ON square equal to OM square plus MN square. ON square equal to OM square plus MN square. Right?
Okay, sir.
R square equal to A plus B cos theta square plus B sin theta square.
Okay, sir.
You are writing?
Uh, Actually, I stopped at cos theta equal to xm by xn because you were writing fast. I'll just write that. Please wait.
Okay.
So can you also please share the PDF?
Yes, I will share. I will share. But what is that? When you will write,
Yes,
uh,
sir.
you will gain
I'll
extra,
just
and
yes,
there will be some practice during the class.
yes. So,
In last class, you got PDF
I don't think so. No.
on this number, your father's number. I have already sent.
Okay. Then I'll go and check it. Yeah. Yes, sir, written.
Now, r square equal to a square b square cos square theta
Yes, so.
2ab cos theta
Okay.
b square sin square theta.
Okay.
And when b square sin square theta, you already know sin square theta plus cos square theta equal to 1.
Yes, sir.
So when you take common b square from here, it will be 1. So it will be a square b square plus 2ab cos theta.
Okay.
Yes.
Okay, sir.
This is magnitude of resultant vector.
Hello.
Yes.
Yes, sir.
What direction?
I was not in the meeting for like 2 minutes. I wasn't able to join because of the network connection.
Okay. So write all the things here.
Yes, sir, right then. Sir, written.
Okay. So tan beta. Now, from this diagram, or you can say from right angle triangle OMN, we have to find out tan beta. and tan beta will be equal to mn upon on. And when you put the value of mn, that it will be b sine theta upon a plus b cos theta. Yes.
Okay.
So tan beta, we have already discussed that when we find out direction, in that case we have to find out angle, and tan beta equal to perpendicular by base, and here perpendicular is mn, that is perpendicular is mn, that is b sine theta, and base is a plus b cos theta. So tan beta is b sine theta by a plus b cos theta.
Okay, sir.
So here tan beta will be b sine theta by a plus b cos theta. Yes.
Okay, sir.
Beta equal to tan inverse b sine theta by a plus b cos theta.
Okay. Okay, sir.
ठीक है.
Okay, sir.
In this case 1, when theta is 0, then r equal to a square plus b square 2ab
So,
cos 0. Cos 0 is 1,
yes, sir.
so it is a square plus b
Yes.
square plus 2ab. So it will be a plus b whole square square root. So r equal to a plus b. Yes,
Oh,
this is the maximum value of a. So it is r max.
okay, sir.
Case 2, when theta is 180 degree, cos 180 degree equal to -1.
Yes, sir.
So r equal to root under a square plus b square minus 2ab.
Yes, sir.
It will be a minus b, a minus b whole square square root.
Yes, sir.
So it is r minimum is a minus b. Case third, theta is 90 degree, cos 90 is
Uh,
0,
0.
a square plus b square, 2ab cos 90 is 0, so it will be a square plus b square.
Okay, sir. Okay, sir. Okay.
We can calculate different value of r by putting their different angle, but maximum value is when theta is 0, r max, maximum value of magnitude, and minimum is r minimum when theta is 180 degree.
Yes, sir.
So this is minimum value and this is maximum value.
Okay, sir.
when you are in class 11th. In this case, you should know how to find the angle up to 180 degree. Up to the 10th class, you use the angle up to 90 degree, like 30 degree, 45 degree, 60 degree, 90 degree. But in this class, we required beyond 90 degree up to 180 degree.
Okay.
So in
Okay.
some of the cases, there may be use of 120 degree angle, 150-degree angle, 135-degree angle. In next class, we will discuss how to find, how to memorize the other angles more than 90 degree. In
Okay.
all,
So basically, the next class would be of trigonometry, right?
I will take 10-15 minutes times of trigonometry.
Okay. Okay.
I will use mathematics only that is required in physics.
Okay, sir.
In some case, it there is when there will be requirement of differentiation, I will do that. When there is a requirements of integration, I will do that.
Okay, sir. Okay.
Because already you are taking tuition of class math.
Yes, sir.
But what is in math? Some chapters are according to their syllabus. First chapter will be something different. Second will be different. But
Eh,
we need immediately differentiation or integration that will be taught in class 12th.
Yes, sir.
Uh, so math teacher will teach in class 12th, but we require now. So in that case, I will do according to that.
Okay, sir.
Okay. Now, now types of vector. One is equal vector. Equal vector. If A and B are two vector,
Yes, sir.
two vectors, and their direction and magnitude are equal. Direction and magnitude are equal. This is wrong sentence.
Oh,
Magnitude are equal and direction are same.
okay. Okay, sir.
Same direction and equal magnitude.
Oh,
Their direction are same and magnitude are equal. If then this is equal vector.
oh,
Means this is A, this is B. And magnitude of A equal to magnitude of B. In this case, it is equal vector.
okay, sir. Yes, sir, written.
Next one is negative vector.
Okay.
If A and B are two vectors,
Yes, sir.
if their magnitude are equal
Yes, sir.
and direction is opposite,
Okay.
direction opposite,
Okay, sir.
like A and B.
Okay, sir.
ये क्या कर रहा है? Here magnitude are equal, direction are opposite, so it is A equal to minus B. This represents opposite direction, this
Okay, sir.
represents equal magnitude, so it
Okay.
is negative vector. Here A is equal to negative vector of B.
Okay, sir.
Yes,
Yes, sir.
ठीक है. शौर्या, इसके भी डेफिनेशन जो है ना लगभग बहुत है.
Okay.
6-7 और डेफिनेशन होंगे, उसके एक्सप्लेनेशन भी होंगे.
Okay.
और जो एडिशन ऑफ वेक्टर है इस पे कुछ क्वेश्चन आप कर सकते हैं,
Okay,
लेकिन
sir.
मैं मैग्नीट्यूड को थोड़ा रिप्रेजेंट करता हूँ आपको. एक दो एग्जांपल और लेने के बाद हम क्लास को फिनिश करेंगे आज.
Okay.
क्वेश्चन. वेक्टर A इक्वल टू, जनरली इट इज रिटन एज 4i, not 4i, it is ai plus bj plus zk ck. What is meaning of here I jk? I cap, j cap, k cap. This cap represents unit vector. This cap represents unit vector. Unit vector means magnitude 1. It represents direction. It represents direction.
Action.
This is for x-axis. This is for y-axis.
Yes, sir.
This is for z-axis. I cap x-axis, j cap y-axis, k cap z-axis.
Okay.
X-axis, y-axis, z-axis. In this direction, unit vector is I cap. In this unit vector is j cap. This is k cap.
Yes.
आई जे के।
Yes.
इसके बारे में हम डिटेल आगे करेंगे, बट सिंपली आप सपोज करो कि यहाँ पे मैं एक दूसरा एग्जांपल लेता हूँ। वेक्टर एक ए है और मैंने यहाँ लिख दिया 4i कैप प्लस 6j कैप प्लस 3k कैप। और दूसरा वेक्टर बी है और ये है 3i कैप प्लस 2j कैप माइनस 3k कैप। तो अगर मैं इसको सॉल्व करता हूँ, सॉल्व सॉल्व में ए प्लस बी निकालना है मुझे। ए प्लस बी इक्वल टू व्हाट एंड ए माइनस बी इक्वल टू व्हाट। तो ए प्लस बी का जो पार्ट है उसको सिंपली आई के साथ आई को ऐड करेंगे, जे के साथ जे को ऐड करेंगे, के के साथ के को ऐड करेंगे। तो एडिशन में ये दोनों ऐड होगा, ऐड होगा, ऐड होगा। तो ऐसे कंडीशन में 7i कैप प्लस 8j कैप और ये तो जीरो हो जाएगा, प्लस 0 के कैप आ जाएगा। 7i प्लस 8j आ गया एडिशन में। सब्ट्रैक्शन में अगेन 4 minus 3 1, 6 minus 2 4, and 3 minus 3 is 6. So a minus b equal to I cap plus 4j cap plus 6k cap.
Okay, sir.
इसकी डिटेल हम करेंगे, बट अभी इतना ही।
Okay, sir.
ये यूज होगा
Sir, done.
ओके। तो आज की क्लास इतना ही रखें, सॉरी।
Yes.